about helium? How many electrons do I have in helium? 2. 2 electrons. I want to fill my first energy level before I can move on. So I have this 1s. Well, the S is one shape, one orientation, which means there's only one orbital. Back to our bell work, how many electrons could fit into an orbital? 2. So if there's only one orbital here, I can fit 2 electrons in it. So the 2 electrons for helium are both going to go in this 1s energy level, 1s sublevel. Yeah, Ellie.
So you can fit 2 in it, but you don't have to have 2 sublevel?
Correct.
Okay.
It has the maximum capacity to hold 2. It doesn't have to have 2 in it. And with the P, how many did we say the P, so the S has one orientation, meaning it has one orbital. Later on we'll draw these as boxes, so it has one box. The P had how many different orientations? 3. So it had 3 orbitals. So I could draw that as 3 different boxes. How many electrons could fit in that then total?
6.
It has the capacity to hold 6 electrons, even though there's only 3 orbitals. Let's go through the other ones. This is good practice. So the D has 5 different orbitals. So I could draw those as 5 different boxes. How many total electrons could fit in a D sublevel? 10. And then the F, turns out it has 7 different orientations. So I would draw that as 7 little boxes. So it has the total to hold how many electrons? 14. So it has the max capacity to hold 14. Max capacity to hold 10, but it does not have to contain that many. Okay, so if we jump ahead a little bit, to neon, excuse me, not neon, nitrogen. Nitrogen right here. How many total electrons am I trying to write an address for? 7 electrons. Okay. I have to start with low energy, so that's going to be the 1s. And we said that that's only one orbital, it can only fit 2 electrons, I'm going to put 1s2. Once I fill the 1s, I move on to the 2s. Well, that's only one orbital, that can only fit 2 electrons. I have more than 2 electrons to place, so I'm going to put 2s2. After the 2s would come the 2p. It has the maximum to hold 6 electrons. I'm only trying to place 7 electrons. So I've already placed 2 here and 2 here, meaning I only have 3 electrons left. So there's got to be 2p3. Questions? Give me thumbs up if that makes sense. Thumbs down if it doesn't. Yeah, answer?
How do we know where you change it to add or
So when do we throw in a 4s and then a 3d? Like when does it go out of order, you mean?
Yeah.
We could follow this pattern. And so we've done the s, we've done the 2s, we've done the 2p.
But look at it if you're
We'll get there. We'll get there. I think I know what you mean. And you'll have that again. You'll have that as a reference page. Does that answer your question? Yeah, Tyler. You will have that as a reference page. So some of you know what this is already. Some of you don't though. So don't give away the ending. No, you don't. You don't need it. You'll be fine. Alright, so now let's try magnesium. Magnesium has how many electrons? 12. Take a moment. How would you replace those 12 electrons for magnesium? Magnesium being right here. Okay, 1s2, 2s2, 2p6, 3s,
2s, wait,
2.
oh yeah, oh yeah.
1, 2, 3, 4, plus 6 is 10 electrons, plus 2 is 12 electrons that we're trying to place. Okay? Now, let's look at this one. When we had hydrogen, just 1 electron, that fit into the 1s1, so that was an s electron. When we did helium, 2 electrons, that was unit 1s, meaning that helium was also an s electron. After I filled the 1s, I start moving into the 2s. So if I had done the configuration for lithium, it'd be 1s2, 2s1. So that's an s electron. Beryllium is also an s electron. We just did magnesium, and those electrons ended in, guess what? S.
Let's do lead.
So, these 2 columns on the far left side of your periodic table, this is what is known as the S block. If you have elements on that far left side, those are electrons that are going to go into your S sublevel for the particular energy level that you're in. Any sense? How many electrons did we say could fit in the P? 6. Well, when we were doing nitrogen, we had some of those electrons ending up in the P sublevel. So nitrogen has P electrons. Does that mean carbon would have P electrons?
Yes.
Yes, because take away an electron, it'd be a 2p1, a 2p2. Boron, take away another electron, that'd be a 2p1. If I keep going to neon, I can do a 2p6. So 6 total electrons fitting in the P sublevel. 6 electrons, those are going to be, the 6 elements across here are going to end up being the P electrons. Yeah, Owen.
What about helium?
What about helium? So helium, we've already written out helium. So helium's the exception, it fits in. So we're trying to put helium kind of more like this. There's helium in the S. So I forgot that I had labeled him as. So more like those ones are your P electrons. Helium is still an S. Thank you for that clarification. How many electrons are supposed to fit in the D sublevel? 10.
What? Oh yeah.
5 orbitals, 10 electrons. Can you count how many elements
10.
are in this section? There's 10! Isn't that cool? That means that these, right there, have electrons in your D sublevel. How many electrons are supposed to fit in your F block? 14. How many elements are here? 14. how many electrons should fit in those orbitals, and it happens to work out that the way we organize the periodic table matches the number of electrons in those orbitals. Hello! Sure. Hello. Oh, she came in with a pass. Sorry, and I didn't have it ready, so. Thank you. Alright, now, something to note, on your periodic table, which I'm kind of a periodic table snob, but I like this particular periodic table, so, but I'm telling you, that on your periodic table, it actually lists out LA and AC down here, right? Which gives you 15 elements in the F block, not the 14 that you should have. That periodic table at the back of my classroom does the exact same thing. You'll notice that instead, up here, they have like a range, so they're going 57 through 71 as the elements that fit right there. And 89 through 103 as the elements that fit right there. So there's a gap there. I would like you to know that these two elements, lanthanum and actinium, those are D elements. Those electrons would end up in the D sublevel. Starting with cerium and thorium, those ones are your F electrons. So please make sure that you've labeled LA and AC as D electrons and everything else as F electrons.
What is the bottom two then? Are those F?
These bottom two are F. These bottom two are F. And so they give us the 14 F electrons that we're expecting to see mathematically based off Schrodinger's equation. This is a nice resource that conveniently gives you the Aufbau principle in order. I put this on orange paper so that it's a resource, so that you don't lose it, so that you keep it with your periodic table. And it looks something like this. So it kind of clarifies, oh, it's frozen, sorry.
Why do you have to do states for
So this is another way to notate your SPB and F block. Keep it in mind that your F block starts with cerium and thorium, not lanthanum and actinium. Okay, so